PIV, there's one final calculation, PIV, which is the voltage peak reverse voltage. What does that diode feel when it's reverse biased? How much voltage will it feel when it's reverse biased? So this diode is open. What is the voltage across that diode? That's what PIV means. And this is important when you size the diode, when you're designing one of these circuits. So that's V out peak. So that's V peak rectified plus 0.7. There's 2 or 3 ways of finding the PIV. This is one way of finding it. And I know what my V peak rectified is. It's 9.9. And I add 0.7 to that, and that gives me my PIV rating of the diode. How much? 10.6. So this is information that I use when I design the circuit and I want to size the diodes. Okay, so now let me show you where these equations are in the document. Yes? Yes, VDC average is by output. So this is output voltage at RL. I have all of these notes in a PowerPoint format on DC Connect, but some of it is shown in the appendix as well. So if you go to page 8 of the appendix, go to page 8. And this one page summarizes the equations and the graph and the values. Okay? So that's appendix 1. Appendix 2 is adding a capacitor, which we're going to talk about in a minute. But first, let's draw the graphs. Let's draw the graphs and label the graphs on page 2. Because on a test, in homework in the labs, you need to draw these properly. So, the 2 graphs on page 2, the top graph is B secondary. B secondary. So the first thing I do when I show a graph is the 0 volt line. So 0 volts is right here in the middle. And the next thing I show is the peak value. So what is the peak value? Tell me. 11.3. That's all. Yeah, it's understood, but if you really want to, then I think it's a good idea to show the negative 11.3. Okay, the second graph below it is the graph of V out. And what's V out going to look like? It's going to be those pulses that we show. For the positive half, the pulse is like this. For the negative half, same pulse and same and same. You can use the dotted line as your guide and draw those pulses for the positive half and for the negative half of the B secondary. Again, we show the 0 first, and then we show the peak value. How much? 9.9? Yes, 9.9. And information. This is one cycle here. On the secondary side, what is my one cycle on the output side? It's half of that, isn't it? Actually, in terms of frequency, the frequency is doubled because the cycle is here. So this is for the input, the frequency on the output is doubled. Okay, so that's without the capacitor. Now, what we're going to do is for this circuit that I have, I'm going to add a capacitor. And if I put a big fat capacitor, okay, in the lab, that's what we're going to do. We're going to add a big capacitor. But if you're adventurous, and we've had a number of capacitors popping and melting and all kinds of things, okay? And you have to wear your safety glasses. We cannot emphasize enough that you have to wear your safety glasses, okay? Please wear safety glasses because one incident, okay, and we have to call the ambulance. Because what if that capacitor explodes and it hits you in the eye? Okay, so what if we put a big capacitor in my circuit? What I'm going to see is this. Watch. That's what I'm going to see. And some of you saw that with the 2-diode rectifier circuit that we built this week. And so what do you think will be out with the capacitor, with a big fat capacitor? How much will it be? Close to 9.9 volts.